welcome to our today's lesson. That is also still going to be on properties of matter. And as you can see on the board, in our last lesson, we looked at properties of matter, and we looked at the general characteristics, the characteristics of this matter. And in this case, there are summary of whatever we looked at that the other time. We say that we have three types of matter. We have solids, liquids, and gases. And as you can see here, we mentioned that solids have a definite shape. So I've just made this particular table in a simple way. We have shape, volume, and mass. On this side, we have the different types of matter. We have solids, liquids, and gases. So when it comes to the shape, it has definite shape, that is solid. Volume or is also definite. And we mentioned that all solids take a certain shape. So we will talk of, if that has a good shape, then we talk of it as a definite shape. Volume as well, that is definite. Mass as well, you can weigh how heavy they are. When it comes to liquids as well, liquids have no definite shape. And we did that by saying that water takes the shape of the object that it is put in. Like talk of water in a container, like a bottle, a drinking a water bottle. It takes the form of that particular bottle. Even if it's a bottle that looks like that, it will just take the form of it. You put it in a glass, it takes the form of the glass. That's why we say that liquids have no definite shape. They have no definite shape. I don't know then. So I can talk of no definite, still the same. It doesn't have a definite shape. So you talk of no definite shape or not definite. Then volume is definite because practically a container like this has its own volume that it can carry. So water, all liquids have a definite shape, and then automatically mass, we can weigh how heavy it is. So it has a definite mass. Then gases, automatically we can weigh them. That's why we talk of a balloon. A balloon with air is heavier than a balloon without air. Talk of a ball. A ball without air in it is lighter than a ball that is fully inflated with air. I'm still going to use my balloon. When this thing has air the way it is, and another one has no air, these things are very different. And hence we must acknowledge that in that particular capacity. And then the next thing again is about the gases. The gases have no definite shape. The shape, look at the way this one now is. A gas cannot have any shape. Look at this, there is no air here. When I put air in it, the air will take the shape of whatever it is put in, just like water. So you don't say it can't have definite shape, so not definite. Comes to volume, volume is also not definite. Doesn't have definite volume. So I'm going to do some very few experiments here to explain certain things. There is the issue of a simple experiment on air occupies space. The first one is air occupies space. Air occupies space. So look at this. This thing has no air. And as if we put air in it, the air there is occupying the space in this particular object. Where I'm standing here is in a class. In this class, there is air. The air has occupied the space that is in this particular class. A very good example of an experiment being done in class is when you take a basin of water, then you put water in it, a top of maybe 3/4 full like that. And after putting water, then take a glass of water, then take it directly in that position. Take a glass of water directly. in that position. Try to put it directly in the water like the way I put mine. You'll realize that water will not be in the glass. Air that was there will take the space. You'll occupy this space until the last minute, like this. So air will not enter the glass. Why? Because air occupies space. When an empty glass is pushed directly into water, as I was drawn there in the basin shown in the diagram, water does not enter the glass because the space inside the glass is occupied by air. Because there is air inside air. Hence, this water that is in the basin cannot enter the glass. So now you will try that. You just take a small piece of paper to make you know that indeed there was no water in the glass. Just take a small paper, put in the glass, and then take a basin, the small basin, the one for washing hands. Take that small basin, put water in it. Then take the glass directly. Take the empty glass directly into the water in the basin. Then leave it here for about 1 minute, and then remove it. When you remove it, that the paper is still there and dry. Meaning water did not get into the water, the glass. That means that air occupies space. Another experiment we are going to do, for me to show that air exerts pressure. Air exerts pressure. Is this one here? When the mouth of a glass full of water is covered by a cardboard, when turned upside down, the water does not pour. I'm going to do it directly. In our case, we don't have a cardboard yet. I'm going to use this milk. The milk packet as my cardboard. Demonstrate this. As well, I don't have a glass, but we are going to use this as our glass. A very interesting lesson, a very interesting experiment. So now this one is I've taken this as our glass. Look at it well, the water is full to the brim. Full to the brim. Then I cover it with my cardboard. Assume that this is my cardboard. Then I turn it upside down, as we are being told. After that, I have the audacity now. Lift it slowly. Lift it slowly, very slowly. Slowly. Sorry. I'm disappointed us already because it's not well covered. Sorry for the disappointment. Let us try again. Nana. Try again. It seems as if it's not working for us well because I've looked for a glass, but I could not find one. Didn't have a glass. So the issue is just as simple as that. You take a glass of water, maybe if you have a glass of water at home, you take a glass of water. You take a glass of water in that manner, put water to fill it, the brim, and then put a cardboard. Look for a cardboard. Hold that like a cardboard and put on top. Then turn the glass upside down. You'll see this particular cardboard will not fall down, meaning the water will not pour, as it has happened in ours here. Because I didn't have a glass, I just got a small cup of water, a cup that has not helped us. So if you turn it upside down, this water here will not fall down. Why? Because of the reason I told you. Right? So the cardboard is hard on top, held on top of the glass. This is because the pressure exerted by the air on the cardboard from outside is the same as the pressure exerted by the water in the glass downwards. So there's pressure exerted here. Let me draw it in that manner. The air exerted pressure. Then there's another air that is coming from this side. Remember this force that is being coming the other side. And this force is the same as the force coming from this side, the pressure. Hence, the bond is maintained. That cardboard will remain. The cardboard that we put there will remain, and hence it will not fall down. So we also know that air can be compressed or made to occupy a small space. Air can be compressed. A very good example of air compressed is the gas we are using at home. The gas we are using to cook at home is a very good example of air compressed. In a very small container, we have compressed air inside, and hence we are able to use it for a long time at home there. So we mention that air can be compressed. Air can be compressed or made to occupy a small space. Or made to occupy a small space. A small space. For example, we have also given an example here. For example, a pump compresses air and pushes it into a car tire. E.g., a pump pushes air first it compresses. A pump compress air and pushes it into a car tube. That is at the tube of the tire of the car. So we're going to go very, very quickly to the effects. The effects of heat. Effects of heat. The effects of heat on matter. And that is the major part of our lesson of today. So we come to this effects, learner, on matter, increase and decreasing temperature. So we talk of increasing and decreasing temperature. How do they behave when we increase temperature or when we decrease temperature? So these ones are another issue of change of states. Change of states. When we add temperature or when we decrease, what happens? So when we increase or decrease temperature of any of the three states of matter, can make them change. Like a solid can change into a liquid, and a liquid can change into a gas. That is the issue here. We have solid can change into liquid, and then we have gas. We also have this direct. Yeah. Meaning liquid can change into a gas. That's to brief you a bit before we go into details, Lana. We have realized that when we eat a solid, let's take an example of ice. When ice is heated, it can easily change into water again. So meaning when we add heat here, when we add heat, to this, it can easily change into a liquid. And again, it comes to liquids again. When we reduce heat, meaning when you put water in a fridge or a refrigerator, you realize that water will become a solid. It will go back to the ice form. So when we reduce heat here, meaning when we decrease heat, the temperature, it can easily come back to what? To solid again. What about liquid? When we heat water, it changes to water vapor, meaning it evaporates, meaning it changes to a gas. When we put heat directly, this thing will change directly to that. And then, when you leave it to condense, this gas again can change into water. When the already evaporated air is left to condense, it can then come back to liquid form, meaning that time when heat is reduced. Here is reduction. When it is reduced, then here when it is increased. When it is increased, liquid will change to gas. When the gas is reduced, when the gases when we decrease the heat or the temperature, it will change to liquid. And then the gas again can change to solids. We shall come to that. And how solids again can change to gas. That is what we are going to learn here, very interesting. So we are going to talk about the first one is melting. And we see the process of melting, how it comes about. Melting. So melting, Nana, is the process by which solids change into liquids. This is now solids changing to liquids. And I've given a very, very good example. I've given a very practical example of ice. So we take an example of ice there. Ice will melt. Will melt into water. Water is liquid. And then ice is a very good example of solid. So we talk of melting there. They melt. So change into liquid because of the increase of temperature. Here we have increase of temperature. So meaning there must be heat there. That's why if you want ice to melt very fast into water, you put it in a direct sunlight or next to a heat. So when you add the heat there, when we increase the heat, the temperature, it changes, melting will take place. And we have been told to do a small example there of ice cubes put under fire, put on fire, you see them melting very fast into water. Then we have this number one. Number two is evaporation. Evaporation. So evaporation is another one. So this is the process by which solids change into gases directly. Solids change into gases by evaporation. Evaporation. This is solids. Solids to gas. So that process, does it require heat? Let's check. Yes. Increase in temperature. So we also increase temperature directly there. A very good example. Let us just take we take something like we take something like the same. Let us check the example given here. When some water liquid is put in a beaker and heated to boiling, the water starts forming steam. Yes. So liquid changes into gases by evaporation. So then I wrote it wrongly. This is liquid. It is liquids changing direct to gases, liquids to gases. Talk about evaporation. So you just take water, heat the water, and you see the water evaporating in the air, meaning the liquids, the there, through evaporation will change to the gases that we are seeing there. So that does also mean increase of temperature. Increase of temperature. And then we go to our third one. Our third one is something called, that one is condensation. Condensation here, that is number 3. In condensation, this is the process by which gases change into liquids. Gases change into liquids. And the process requires decrease in temperature. We decrease what? The temperature. We decrease the temperature, meaning when the gas is evaporated, we reduce heat, and then we see the gas changing again to liquids by condensation. Condensation. We have also been the diagram drawn there. Looks like this. There should be a source of heat. These are stands. So there's heat being applied. Then on top of it, we have a source of like a sufuria being put there. And after the sufuria, we have another container like that. So there is water. There is water here that we are heating. And this water will produce steam. The steam will go up there. The steam. This is hot water. Hot water. Hot water produces steam. And then when the steam goes there, the steam will form. This is cold water. This is cold water. Then the steam will form some water droplets down here because the one up there is automatically cold. So when the steam goes there, we see the water droplets condensing here. So the steam, the water here has been heated to form steam. Steam is air. So when they go here, they change again into what? Into water. Why? Because of the cold environment in this container. So these ones are called water droplets. So the droplets are formed because of the cold water that is up there. Then we now say that a cloud is formed by condensation. This one is now the practical form of what we normally see happening. What normally see happening, we'll see the clouds always form. The clouds form. Why are they formed, Lana? When the water down here evaporates up, just like it's happening here. The clouds is formed by condensation. When water evaporates from the ground, it reaches the cool sky and condenses back to water droplets, which stick together to form clouds. So these clouds are just a very good example of water droplets that form because of the water that has evaporated. Once the water evaporates, it's hot. So in regions there, it gets a cold environment in the sky. Remember, the higher you go, the cooler it becomes. So as we continue going up, we have a cold environment up there than down. Here is very hot because the downer part is normally hotter than the upper part. That's why you go to the top part of the mountain, it's very cold. And on the flat ground like this, it's very, very hot. So the hot air reaches the cool play part, becomes again into those droplets, and those droplets will automatically form the clouds. They stick together to form the clouds. Then when they become very heavy, they fall back as rainfall. And again, we go to another one that is now going to be freezing. And freezing is going to be the last one. Freezing. Freezing is known by almost all of us. This one is a very easy one. Freezing. So freezing, Lana, is the process by which liquids change into solids. Liquids change into solids. It requires decrease in temperature. Putting water in the fridge, putting fish in the fridge, putting meat in the fridge. Remember that? We put that to make it not to be spoiled. So when we put solids in change them into take liquids, change them into solids. Like for example, just water or juice, as you normally do at home. You take water, you put it in a bottle, then put it in the fridge. It becomes a cube, like the ice cubes. It becomes a solid like ice. So that one takes place because of the decrease. The fridge is very cold, so the result of decrease in temperature that makes that to take place. So when some water is in a small container, is placed in a deep freezer, it solidifies into ice after some time. So the temperature at which a substance melts is the same temperature at which it freezes. The temperature in which a substance melts, like ice, is the same temperature at which it can freeze. Then the temperature at which a substance evaporates is the same temperature at which it condenses. So I'm going to draw a summary, something to summarize whatever we have done this short time. Then we call it a day. Waiting for next time to continue. We have, let me write in capital letter, solids changing into liquids, liquids changing into, let me get a bigger space, liquids changing into gas. So this processes here is what one will see. Which one do we decrease, which one do we increase? So liquids directly, solids to, let me draw some boxes here to make you see them well. So we have solids to liquids here directly. We talk about melting. And melting requires decrease in heat. Solids to liquids. I give an example of ice. Ice is our very good example here. You always write it there. Ice will change to water by melting. And melting requires increase heat. Increase heat to make it to melt. What about liquids to this one? Liquids are the one we have just done last. Water back to ice. We talk of freezing. And freezing requires decrease of temperature. Always talk of decrease of heat. We decrease heat. Napunguza, meaning the environment must be very cold to make it that one happen. Then what about liquids? They evaporate. Liquids to gases here, we need evaporation, that we also need evaporation. And evaporation requires increase of heat. We boil water to change into gas directly. And then lastly, condensation. So here we can give an example of water vapor. Then gases directly to solids here. We need condensation. And condensation requires decrease in temperature. We decrease heat there. So all of these ones go down, look at them. Here we decrease temperature, and up here we increase temperature for them to take place. Now until that point, someone has to stop there. And our next lesson, we're going to look at the last part, the last bunch of it. That is expansion and contraction of matter. what happens to matter when it contracts, okay, what makes matter to contract, and how will they contract and expand. So until next time, I want to wish you a busy day, remain safe, until next time.